Hi, myself Manishankar. I am working as a MATLAB programmer in Spiro group of companies. Now I am going to explain about the project known as face recognition across non-uniform motion blur, illumination and pose. In existing method has lot of disadvantages known as in which we cannot identify the face if it has blur or if it has any of the blur and illuminations. If it varies continuously, we cannot identify the face, that who is authenticated person. In our project, we can identify any face, that is authenticated face, if it has any blur or illumination or any pose. This is a basic concept of our program. We have broadly differentiated the existing system and the proposed system. Now I am going to explain about the existing concept and the proposed concept. In our existing concept, we are recognizing the face in the presence of blur and using convolution model, and it cannot handle non-uniform blurring. In the case non-uniform blurring, in the sense if the image is changing continuously, it cannot identify the image, and the blurring is caused mainly due to the presence of, if we shake the camera while taking the image and model convolution with a single blur kernel, because here we are using a single blur kernel so that it cannot identify the who is the authenticated image. In the proposed concept, we propose a methodology for face recognition in the presence of space varying motion. This is the concept we are using here, space varying motion, blur composing of arbitrary shaped kernels. This is the advanced kernel regarding to the existing concept, and this is what I so explained here. And here we are differentiating the existing technique and the proposed technique. In the existing technique, we are using the direct recognition blurred face DRBF, and in the proposed algorithm, we are using space invariant blur. Okay. Now I am going to explain about the technique which we are used here. A pixel is in a blurred image is weighted average of the pixel neighborhood in the original image, and thus blurred image is modeled as a convolution operation. This is what performed here, and the blur kernel is possess an additional structure depending on the type of blur, and the structure could be exploited. This is what we are performing in DRBF, and in the proposed technique we are using a handling images blur shake, and this is caused because of camera shakes. We synthetically blur and focus the gallery image. We have already some gallery, that is deriving all the data regarding an image which could be possibly blurred, and we are making the image look like an original image through which we get the authenticated image. Here we are differentiating about the drawbacks and the advantages in the present model and the existing model. As sparse miniature technique is recognizing faces across simulation, so it cannot identify the new image which is identified image. It has advantage of mobile video identity resolution and surveillance applications. It has lot of applications from 2D transformation to 3D transformation. It is very accurate and it can be used widely. This is a block diagram here which focused image, focused gallery, and it is converted into three modules known as blurred observatory, convolution model and space invariant model. The image is going through all these spaces and we get an output known as blurred illumination and pose. And using here we recognize the face and we show which is authenticated and which is not authenticated image. There are a wide variety of applications from each and every where we require an authenticated person to use the authenticated system. Right from the passports to driver license and etc. These are the requirements for this project. It requires a normal processor of Pentium dual core and a hard disk of 40 GB, RAM of 2 GB, keyboard of content keyboard, that is known as QWERTY keyboard, and this is a future enhancement. It has a few limit. In future we have a lot of idea for this, making it more useful, and we can reduce the approach by accuracy and efficiency, which is most important. Now it is efficiency is higher, but still in future we can improve the accuracy to its maximum. And thank you.